Hi, welcome back. So in this video, I'm going to briefly talk about how to use the AFG, which is the auto function generator, an inbuilt feature in this oscilloscope. This AFG allows to generate different types of waveforms, which you may need to apply to your test setups, to boards. So basically to generate and apply a test signal. The AFG is generated by a BNC port, which is on the back of the machine. Right now it is hooked up, and you can see this cable, BNC cable, is coming from the back of the machine. I'm just going to show it to you where this connector physically is. So now we're looking at the back of the function generator, back of the oscilloscope, and you can see that's where AFG is connected. And if I turn the scope a little more, you can actually see there's the AFG out, and that's the far right connector on the back of the oscilloscope. So this is a signal coming from this is a BNC cable coming from the back, connected to the AFG connector. And this red wire here on this BNC cable is bringing the signal from the AFG, whereas this black connector is bringing the ground. So I have connected. I'm going to check these signals, set them up on channel number 1, which is a yellow channel, and as you can see here, I have a yellow ring, and here. So that's where it is connected. So you can monitor it on channel 1 and configure and change it. So AFG button is here, right on top of probe 1. I will press that, and it will turn on whatever the waveform was previously set last time. So last time somebody was using a square wave, and to change to any other wave, what you can do is you can press this option button, and using this multi-purpose knob, you can select ramp, pulse, square, sine wave, arbitrary signals, etc. You can also apply DC level if you need to, so or noise for that matter, and some other functions which I have not used myself a lot. So so you can explore these things. So let's go back to the square waveform. A very good signal for digital applications, or if you're going to do some timers or pulse width modulation. This kind of a signal can be a good test signal to generate and test your circuit. So you've selected square wave, so you can press that button to clear it. Now we can go to waveform settings. Right now you can see this frequency has been set to 1 kilohertz, and I am doing a measurement here of frequency, and it is showing 1 kilohertz frequency. So what I'm supplying through these settings, let's change it for the matter of argument. So when I can change things either by period or by changing the frequency. Let's change it by frequency. So let's change it to 2 kilohertz. So I'm going to press, the easiest way is to use this keypad here. I'm going to press 2, and I have these options: hertz, kilohertz, megahertz. Let's say 2 kilohertz. And there we see the frequency changed, and same thing here, the frequency changed to 2 kilohertz. Just like we set, and you can also see that just like I changed the frequency, the period automatically updated to reflect the frequency right now. Next we see amplitude and offset options, and also so right now it has been set to 2 volts peak to peak. So we can see right now there's a 1 volt plus and 1 volt minus, and there's an offset of 0. So AFG is by default is giving us symmetrical signal, around DC values. So we have both plus and minus signals. If, for example, if you wanted to supply this to a microcontroller or some other kind of a digital circuit, which only is going to accept 0 to 3 volts, for example, or 3.3 volts, So we can change the amplitude from here. What we can do is, let's change peak to peak to 3.3 volts. 3.3. Oh, that's not 3. So we can always backspace. So 3.3 volt peak to peak. So now we see there's a peak to peak voltage, but you can see the high level is, now these two are interrelated. Amplitude offset is interrelated to high level and low level, and you can see they automatically update. Now I'm seeing high level of 1.65 and low level of minus 1.65, because we were saying that we want to apply this to a digital circuit or to a microcontroller as an input, so which typically accept signals between 0 and 3.3 or even 0 and 5 volts. So how do we do that? We can simply apply an offset here, or we can change low level to 0. Either we can apply an offset of plus 1.65, or we can do, say, low level is 0. Let's apply an offset of 1.6 volt. So I'm going to apply an offset of 1.65 volts, and boom, there you see. Now my bottom part of the wave is at 0 level, and the top part is at 3.3 volts. And this is what we would typically apply as a test signal to digital circuits or setups which take 0 to 3.3 volts. If, for example, if it was some Arduino setup and which accepted 5 volt, 0 to 5 volt, so what we can do is go to high level here and change that to 5 volts. And let's see. When we do that, you will see this offset should turn to 2.5, because our low level is still 0. So I'm going to change it to 5 volts. There you see the offset has turned to 2.5 automatically. And so now, because our low level was 0, so now we are 0 to 5 volt. The triggering has, so let me trigger it properly. Here I'm moving the trigger level, and we're triggering the signal now. And you can see again we have a signal which is good to apply to a digital setup, or Arduino, for example, which typically takes signals up to 0 to 5 volts. So a signal like this could be applied there. The last option here is duty cycle. Often we use 50%, but if we were to use PWM or some pulses, so we can change this to, by say, let's say we want to press 25%. So we rate 25, and percent is the only option available. And you can see our signal is high only for 25%, and remaining 75% the signal is low. So this is how you would use the AFG function. Once you have set everything up, you can clear the menu by pressing the menu button off. And as you can see, our value is frequency is 2 kilohertz, and our scale, vertical scale, which is voltage scale, is 2 volts per division, and our time scale is 400 microseconds per division. This is it about the AFG. Thank you very much for your attention.